Hi, this is your host Flynn and welcome to TFR Let's Talk. And today we have with us once again David Flynn, co-founder and CEO of Hammerspace. David, it's great to have you on the show.
Hey, glad to be here, Swat.
Of course, you folks are regular here, but it's always a good idea to remind our viewers what is Hammerspace all about. So quickly tell us about Hammerspace.
We abstract data from the very storage storing it and then supply it using the self-same storage interfaces. Talking here about file system. So this basically allows us to orchestrate data across third-party storage systems of all flavors, file, block, object, and present it as file, block, object. So data orchestration is a key part. The other one is global access. So we can move data across whole data centers and serve it up from within those different data centers with local access to global shared data. And then third pillar is hyperscale NAS. So think of it as the performance of a supercomputer class file system, but from something that is standards based and just built in. So hyperscale NAS, data orchestration, global file system. All those three things together allow you to put data in one place and have a data platform that can supply data at the most demanding levels of performance across any infrastructure in any data center anywhere around the world.
Thank you so much for that introduction. Now, today's topic is more around GPUs. First of all, I want to talk about what role are GPUs playing in the data center cloud data space.
We had been working pre the AI explosion. We had been working with folks that use GPUs in and around the world of media and entertainment, animation, special effects, rendering, that type of thing. So it's not like GPUs weren't being used at all, and in rather data-intensive workloads in the world of media and entertainment. But now, since they are the foundation of AI, large language model and multimodal models, you've got to pump huge amounts of data through these GPUs, especially on the training side, but also on the inference side. So both training and inference and fine-tuning, it's all about doing matrix multiplies, and that's what GPUs do very well.
When it comes to your own data center, where you are kind of building a cloud-native, cloud-like experience for your teams, what kind of challenges organizations face when it comes to GPUs? I'm not talking about just procurement of GPUs, the cost of GPUs, but a lot of other things.
Well, yeah, I mean, just to touch on that briefly, obviously, availability of GPUs has been a challenge, especially those on the bleeding edge. But even with that, you have the issue of getting enough electricity to power them. The power density requirements often blow through any kind of power budget that you might have in your facilities. So that's actually leading on to a trickle-on effect that's somewhat surprising, with folks moving away from mechanical hard drives so as to reclaim wasted wattage. Spinning rust takes a lot of power, and going to solid state can take not only a tenth, but even a hundredth or less the power versus a hard drive-based solution. So even though flash is not cheaper than disk on a sheer capacity basis, when you consider the opportunity cost of wasting the electricity for spinning platters in a hard drive versus being able to power GPUs, there's a reason to get rid of those hard drives and to pay a bit of a premium for flash. But this goes to the issue that GPU-based computing has this problem of being super power hungry, and it will blow through any budget that you have. So anywhere else that you can save on power basically equates to more GPUs that you can use. But the net impact of the shortage of GPUs and the challenge of powering them and finding a facility to run them in is that the industry has to move to a time-shared model of cloud. This has to be a leased resource. Also because the training workloads are rather bursty. It's hard for any one organization to keep them occupied all the time. Unless you're doing hero scale stuff like Meta or whatever, then you're going to keep as many of them as you can get. But most organizations, you'll go through phases where you're training and you need a lot of GPUs. Well, it would be silly to dedicate your own infrastructure to that when you're only going to be using it a fraction of the time. So we have to go to a leased model. You need to be able to use cloud just for the time sharing capability of it. The further challenges that arise once you say, okay, we need a burst model because this is very bursty workloads. It's hard to get enough electricity. It's hard to get access to the GPUs. Then you have to move to a world where instead of moving the compute to your data, which has been the traditional wisdom is move compute to your data, now we have to do the exact opposite. Move the data to where you have the computing capabilities, where you can find the GPUs. In other words, computing has grown to such a scale that you can't shift the computing around because it's not like just running a program in a different place. You actually have to physically rack and stack GPUs in mass. So we have to be able to move the data to the GPUs instead of moving the compute to the data. This brings right up exactly what Hammerspace does, which is orchestrate data. Think of us as data logistics and doing it behind the scenes so that from the point of view of your users and your applications, they just have the appearance of everything everywhere all of the time. But what data is actually in which facility, what data is actually in flight, that actually is now hidden, doesn't matter. It might lead to slightly longer delays on the initial access, but ultimately the data is getting repositioned and will be crazy high performance of local access in whichever facility you need it. So we are a data logistics company. Our data platform is what can move data across different storage systems, across different data centers, and then deliver it in mass parallel at unprecedented levels of performance using a standards-based approach. That's the hyperscale NAS.
What kind of challenge organizations face? Because we are creating and collecting a lot of data, the data volume is also growing. So moving data can also be challenged, it can be costly. So if you're running your own data center, how does Hammerspace help, especially in the SPC environments, to move data where the GPUs are so that they can extract the value that they want to from it without incurring heavy cost and resource consumption?
Hammerspace can help the challenges of moving data across different data centers by using some of the same principles, by the way, that are used in containerized microservices orchestration, namely breaking things into the smallest unit. Individual files are the things that move. See, the bane of our existence when it comes to operating on large data sets is if you have to move them monolithically, all or nothing, before you can even start using them. So if I have to organize my data into these big pools, and then I have to move it, the whole pool at a time, that's a recipe for A, moving more than I need to, and B, having to wait really long for it all to get there. With Hammerspace, data is moved on demand and proactively by policy, but at the granularity of the individual files. And what that means is that your workloads can start as soon as those initial files are there. Obviously, things like the programs themselves, but the different control files, those are trivial and small and can get there first. And then the specific data files that specific job needs. You shouldn't have to reorganize your data into different groupings and then move things monolithically. That is, a poor man's solution. When you have a system that can move the data on demand and can move data arbitrarily at the granularity of individual files through policy, now you can start running nearly immediately. And anything that you haven't pre-positioned in the right data center will get fetched automatically on demand. So the keys to solving this is granularity, automation. And Hammerspace is very unique in that we are moving files automatically, granularly, not whole data sets, not forcing you to reorganize things into separate groupings just so that you have to move the whole monolith. A couple of other key things that can come in here is the fact that since Hammerspace can move data easily, you don't have to have the bulk of your data stored where you're going to do your computing, which would let you put your data onto a storage cloud, which maybe doesn't have the expensive egress costs. And so now you can have your data stored in something very cheap, even on-prem, even though you're going to compute on it in the cloud. So your storage and your compute now don't have to have the same center of location, and you can therefore put data where it makes sense to centralize the data, and then it gets distributed as if and when you need to use it. In a traditional cloud model, you tend to put your data in the same cloud and in the specific region where you're going to do the computing, because to move it is very time consuming, might involve egress costs, etc. So there's all this reason to try to put your data in the same location where you compute. But with Hammerspace, you can put data where it makes sense for its long-term retention and still extract the stuff that you're computing on into different facilities. So you can optimize your egress and bandwidth expenses in that sense as well. Because there's reason to have data in different places, where you have your GPUs, where it's safest and cheapest for long-term retention, where people need to interact with it, and over the lifetime of the data, those things may change. And since Hammerspace can leave data under a single global namespace and, physically reposition the data behind the scenes, now you can make the best of the complex infrastructure environment in a way that's fully automated and simplifies the whole thing.
Is it possible for you to share some use cases? If you want, you can even name drop where organizations are leveraging Hammerspace, these, as you said, whole data logistic capabilities.
I'm really excited to say that, as clients, we have the likes of Blue Origin. That's Jeff Bezos' space company. And that's kind of cool. They're using Hammerspace to have a common data environment across all of their facilities around the country and into the multiple regions of the cloud. So it's kind of cool to say Jeff Bezos is using Hammerspace as the way to do hybrid cloud from his own company into his own cloud. And they take cold data, and that cold data is retained in the cloud. Hot data is distributed around each of their different facilities around the country and in the cloud. So this allows them to easily optimize long-term retention from near-term high-performance access at multiple physical locations. And this is everything from the engine designs to test firing telemetry to actual launch information, even the marketing department making snazzy videos. So it's like a common data plane across all of these things. So that's one very good example. And we have, one of the largest makers of video games that has offices around the globe. They're using Hammerspace in half a dozen to a dozen different facilities. But some of the most recognizable customers are the likes of Meta. They've blogged about their use of Hammerspace in their LLM training of Llama. Llama 3, for example, they were highlighting how they got 3 times higher efficiency, nearly 95% GPU utilization. And they highlighted how Hammerspace is a big part of their infrastructure environment at being able to deliver data at very low latency, high speed, especially when it comes to interaction with the researchers as an interactive file system. So they're at the pinnacle of the hyperscalers arm race around AI. And another example is Los Alamos National Labs, the U.S. Department of Energy, where they build several of the world's largest supercomputers. They put in a new system about every 5 years, and it's usually one that takes the crown as the fastest in the world. And they are now using Hammerspace in their AI and GPU computing as well. So those are just some. We're pinnacle of the supercomputing world, the pinnacle of the hyperscale hyperscale web world, in the media and entertainment world with gaming, like folks that make the big multiplayer online games, to folks building rockets, or even retailers and financial services companies, banks, folks in the insurance business, or healthcare with hospital chains. It's the same places that use, unstructured file data. Anybody working with a large amount of file data. So industrial design, chip design, obviously media and entertainment, energy exploration, financial services. It's that standard cast. But one of the things, Swap, that's going on that's very fascinating is that in the past, our interaction, especially with unstructured data, has been with a human in the loop. Unstructured data involves images and stuff like that, and that's typically something that has required people to actually perceive, to make sense of, and use. What's new is that AI is now able to perceive the contents of images and actually make sense of unstructured data. So all of a sudden, all of this data that used to be difficult to extract value from is the key for AI. And what that does is it takes the human out of the loop. Now it's machine to machine, and that means file systems have to operate at new unprecedented levels of performance to feed GPUs, that machine in the loop. Without a human in the loop, it doesn't have to go slow any longer.
What kind of new use cases you are seeing which is going to push it even more?
Well, one of the things that we have found recently is that a lot of the uses involve the need for the S3 protocol interface, so that you can push and pull data, from a distributed or edge-like use case. So file protocols are very good for scalable performance, but object protocols are great for access at a distance. And so we have recently released the S3 support, so that you can access the very same data in the very same structure as a file system or as objects in an object store. That convergence of object store interface and file interface is important for workloads that want to, throw things into a bucket from a long distance away, or fetch things from a bucket a long distance away. The HTTPS encryption, the ability to access things over HTTP makes it great for long distance access. So, that's allowed us to address, let's call them more edge use cases, where you have more distributed sources and sinks of data. And frankly, the industry has been moving towards the S3 interface because that's what they've been told is required to cloudify things, because getting high performance and scalable file in the cloud has been so difficult. So we're kind of solving it both ways. We've introduced a high performance scalable file that runs in the cloud, but then also it can be accessed over and as object storage, over object storage protocols. So that's one of the new pieces of news from Hammerspace is the S3 protocol support on the front end. We've obviously been able to store and orchestrate data across S3 and object stores for a long time, but presenting the data over object storage is somewhat new. And that introduces the ability to address these use cases, applications that are built for it.
Can you talk about, of course, within the data community, beyond that, what is the role of data in the modern world?
We have been seeing, I guess Mark Andreessen said, software is eating the world. That's really a little more interesting, is to say that, data, everything is becoming more and more data driven, even the most classical of use cases. Let me give you an example. Energy exploration, oil and gas, taking minerals out of the ground. You would think there's nothing more physical and old school than that. But when you look at an oil field, over half of the value of the oil field is actually the data sets that describe what's in it. So data is more than half of the value of an oil field. Isn't that just a bizarre thought? If you sell it without the data, it's worth half as much. So, data really is the new oil in that sense. If we parallel it, we'll look at Walmart just talking about automating their supply chain. What could be more physical than trucks driving around the world shipping product? And yet even that's revolutionized with automation through data and AI increasingly. So I think we're only starting to enter the second inning, right? The first inning was all this structured data stuff, but this is a new data cycle. It's a new data cycle because we're actually able to use all data, because machines can now be designed to perceive of things that were in the past way too complicated to perceive images and audio and that perception capability and then inference capability behind it is just it means that the bulk of data, because remember, less than 20%, some estimate less than even 10% of data is structured, has a well-defined form, has fields and so forth, database data. The rest, 80 to 90%, is this unstructured data, which has heretofore just been a black box. It's been useless. It's been locked away, as people have had to retain it maybe for government regulation and compliance, but it's not like you could use it. Now you can use that data. And so this really is a revolution for the two main reasons. One, we can make sense of unstructured data. And two, we can take human out of the loop and use the data at the speed of machine to machine. And that has real implications for the volume of data and the velocity of data that you're working at it. And I like to say it's not just the volume and velocity of data, but it's also now the fact that you have to run in different venues, because to get GPU access, you're going to have to shift it to where you have those GPUs racked and stacked and can get power for them. So now there's a huge variety in the venue where you run it, and it's that creates this kind of multiplicative problem. More and more data at ever increasing speeds in more and more locations. It means that managing data in the old way of copying things around, whole data sets at a time, monolithically, just won't cut it anymore. We have to move to where data is orchestrated.
How sticky is the data space that you work in? Who are your competitors, and what kind of edge you have over them?
When you talk about the competitive landscape, I view it very similar to the era of calculators. Remember when your Casio calculator, Sony calculator, back when I was a kid in school, you've got these calculators that could actually draw graphs, right? Or a digital camera, or a world with GPS navigators. We used to have GPS navigators you'd put in a car. You used to carry around a digital camera. You used to have heck, I used to carry a watch. I don't carry a watch anymore, right? So when you talk about competitors, it's like that. Hammerspace, data orchestration, global data platform, having all of your data appear everywhere all the time, instantly accessible with the crazy performance levels, that solves the underlying problem to where I don't need to carry a calculator and a digital camera and a GPS and a watch, all those different things. It's like the smartphone, general purpose solution, data orchestration, hyperscale NAS, global file access. That's the universal solution to data being localized. And we've had all of these different solutions like cloud gateways, the Panzuras, the Nasunis, the Sateras. You don't need that anymore. backup and restore solutions, the cohesities, the convolts, the rubrics, tiering solutions like comprise, or stuff to copy data around and synchronize it, like rsync or other more sophisticated commercial tools. It's like all of that stuff is gone in a world where data is orchestrated. It's the difference between a platform where all of those are just emergent capabilities versus point solutions to symptoms. Hope that makes sense. So do I compete with the Pansuras and the Sunnis, or do I compete with, VAST or Weka? No, I don't compete with them any more than the smartphone competes with a digital camera. It isn't to say you can't take photos with the smartphone. It's just digital camera can't do anything near the wide range of capabilities of a smartphone. So no, you don't need to carry a calculator around anymore in a world with Hammerspace.
So are you saying that Hammerspace is like the iPhone of the data orchestration world?
That's what I'm saying. It's a general purpose solution. It can move data, it can tier the data, it can accelerate the data, it can distribute data across data centers. So that's precisely what I'm saying. You don't need cloud gateways. You don't need tiering. You don't need backup and archival. You don't need these NAS solutions when you can just lay a data orchestrator. So let me be really clear. Hammerspace does not make storage. I'm not a storage company. But the storage vendors, we can sit on top of any of them and orchestrate data across. And this compels them to compete with each other on their merits, not by having the data captive. So you can't use data gravity as a way to have vendor lock-in anymore, right? So to some sense, this offsets the spend in the storage world, because now you can, pick and choose and spend on stuff that's more appropriate, as well as continue to use your sunk cost investments for much longer. In other words, a VAST would tell you, you need to buy my shiny new silo and move all your data from that old one to this one before you can feed your GPU array. We're saying, no. Just overlay Hammerspace on whatever existing storage you have. And you can augment it now with some higher performance, but the bulk of your data can stay where it always was. You don't have to do forklift upgrades. That's the difference between an abstraction layer and a replacement silo. We're not a replacement silo. We're the abstraction layer and orchestration layer. Hope that makes sense. Yeah.
When it comes to data, depending on the industries that your client has, some industries are very well regulated. How does Hammerspace enable that so that they can not only do the check mark with whatever regulations are required for the data, but also actually enable that, or that is out of your scope?
No, actually, it's a really important point. And when I talk about you don't need the calculator and the smartphone and the GPS or even the watch, or you don't need the navigator or whatever. Once you have a smartphone, you have all those functions. Well, compliance to regulatory requirements on data retention and data governance. In a world where you're copying data around, you're basically scattering feathers to the wind. When it comes from a security and a governance perspective, there's no way to tell where all the data has landed, and there's no way to call it back. It'd be like trying to find all the feathers that have been scattered. In Hammerspace, the data stays behind a single pane of glass. It's a single namespace that spans every facility and across all of the storage. And that is step number one to, putting this genie back in the bottle of having the data be governed. Step number two is that the movement of data is now done from behind that pane of glass based on policy, which can easily articulate the constraints. Where is it allowed to be? Where is it not allowed to be? So I would argue, again, that this notion of a general purpose solution, you don't need other tooling to go and catalog and gather up all of the scattered feathers to try to tell where is all of the data. When it's behind a single pane of glass and controlled by it, you have that inherently. It's an inherent part of the solution once you put it behind a single namespace and where its movement is orchestrated. then it is by definition governed in a way that it never can be if you're copying things around and only after the fact trying to catalog, inventory, track, and erase stuff that might have gotten in the wrong place. So we are not a governance solution. We aren't even technically a security solution. But in a Hammerspace world, if I change the security permissions of this item in my single namespace, the access control is enforced everywhere. You can't do that when you've made copies because those copies have different access controls. And you'd have to go and find every last copy and update it. Or the audit trail. In a Hammerspace world, if I turn on auditing so I can tell every last access, then that auditing is turned on everywhere. So security, compliance, all of this starts with having a single pane of glass behind which all of this stuff can exist as one logically unified thing. And so that's why I'm saying this is a general purpose solution where these things just emerge from it. They're just an inherent part of it versus being something done special off to the side. So yeah, not a compliance, not a government compliance or a security solution, but this is still makes a bigger difference on compliance and security than any other product out there. Just by changing the paradigm away from copying.
Do you think now we have everything?
Another important part of the fact that GPUs are a premium thing and require, the power and cooling difficult to get is they can't sit idle. You want to be able to keep them fully occupied. This is one reason why we need to go to a leased model, a cloud-like model, so that you can get a shared use from it. But it's also why we have to feed the data with very high performance. And Hammerspace is unique in that we are standards-based, meaning that the stuff required is built into the OS natively. See, in the past, you've been limited to, if you use that which is built in, think of it like the public roads. And those public roads are surface streets with stop signs and stop lights. And by the way, they're kind of legacy and they have potholes and they're in a little bit of poor repair because they're a public right of way. So this is the world of enterprise NAS, NetApp and Isilon and Cumulo and VAST. The alternative to that is to have it use a custom highway system that's incompatible with any other and incompatible with the built-in roads. That custom highway system basically requires that anybody who's going to use that has to open up their operating system for brain surgery and plug it in and then maintain it. We're talking here like IBM Spectrum Scale or GPFS or DDN's Luster, or if you want something newer and less mature like a Weka. Those exotic file systems come with the requirement that you perform brain surgery on every single one of your machines that's going to access that data to install this highway system. But you get the performance of a highway out of it. Well, Hammerspace, when I founded the company, it was with a mission to build a public highway system and build it into the OS. The attempt to do that, the industry had already attempted to do that. It was a rather academic effort. And because it was designed by committee and because it was a retrofit with incumbents who were trying to continue to use their existing architectures when this really demands a completely new architecture, that early effort kind of failed. But that allowed us to have a little bit of fewer cooks in the kitchen and go and build something that actually works. So my CTO is the kernel maintainer of the NFS client stack, that highway, the road system in Linux. And so we were actually able to build out the highway that's a public right-of-way and where you can go at these crazy supersonic speeds. So instead of having to choose either the old slow surface streets or exotic custom highways that take brain surgery and maintenance to install and run them, we have built a new highway system. And Hammerspace, to date, is the only system that leverages that to get the kinds of hypersonic speeds of hyperscale NAS. Even Dell Computers has started talking about resurrecting their 15-year-old projects called Project Lightning. And that's an admission that we made it work. People had given up on it. And we proved that it worked and that you can get that kind of crazy performance level.
David, thank you so much for taking time out today. And of course, share great insights with us today. And I look forward to talking to you again. Thank you.
All right. I'm sure we'll talk again soon. Thanks.